should go to Zeiss.
Zeiss Digital Partners.
Be amazed of knowledge, industries, manufacturing, optics, hardware, software,
AR, VR.
Machine Learning.
infrastructure.
Ich will nicht aufstehen und irgendwie mir denken, scheiße, ich muss meinen Job machen, sondern was kann ich heute machen?
You will make it happen. Do it.
Give me a... Hi. Our next speaker is George Cave, and he's going to talk about prototyping with hardware and web. If you have questions, type it in the app. And if you will have questions to him afterwards, you can just come to him. Thank you. Enjoy.
Hi, everyone. It's very nice to meet you all here. I'm George, and today I'd like to share with you all the amazing ways you can connect to and control hardware prototypes from the browser. So over the past few years, I've worked through my business, Interaction Magic, on designing and prototyping the interfaces for all manner of products, night vision cameras, motorcycle dashboards, redesigning the interactions on this Casio F91W watch. I'm sat here in the front seat of a car with my laptop, trying to send navigational cues to the guy on the bike ahead with haptics and lights and sounds and things inside the helmet. And in every case, the common theme has been that there's been a screen-based interaction which is complemented and supported by physical controls. Switches, lights, buttons, the small buzz of a speaker, or movement of a haptic actuator. And the underlying technology is always a browser. To be perfectly honest, my job is a lot easier these days because the native browser APIs and the techniques I'm going to show you have reached a maturity that makes them really easy to work with and very quick to iterate. As a heads up, I'm going to do quite a few live demos in this talk. I've never done any of them as a live demo before, so I guess wish me luck. Today we're going to cover 3 core techniques: keyboard emulation, using Web USB, and using Web Bluetooth. And I made one big assumption throughout. You all know more JavaScript than I do. The aim of this presentation is not to teach you the specifics of the code. What I want to do is show you how to get started in all of these areas, the tools, the hardware, the parts you need to buy, and really kind of whet your appetite to go and try this out for yourself. Let's begin. Pretty much everything on a computer can be controlled by a keyboard. Every app, action, command, some associated keyboard shortcut with it. So if we're able to program some hardware that will act and work like a keyboard, we can, in theory, control anything we want on the computer without any custom code at all. And I'm not just talking about programs like Keynote or Spotify or something. Prototyping tools like Figma, you can easily set them up with keyboard triggers to move between the different screens. Key press detection in the browser is obviously really trivial. In my previous job, we built and tested a lot of motorcycle dashboard UIs. And in each case, we'd have a screen with some prototype graphics and some hardware buttons on the side. And the screen was a small HDMI display connected to a Raspberry Pi, running a full-screen web browser. And then these buttons are programmed to work as a kind of keyboard buttons. So yeah, this is a motorbike that runs on JavaScript. And I'd like to show you all now how this whole technique works in more detail. This is an Arduino, this circuit board, but also this web UI people call the Arduino. Arduino is the company name with the logo. I think I and many others just use Arduino as a kind of shorthand for this family of easy to program and easy to control small electronics boards. And if all this is new to you, the basic idea, you buy one of these things on the left. Whoops. You download this free piece of software on the right, which is the IDE, but it's also a kind of compiler and upload tool So you write some C, C++ in this, and then you upload that code onto the Arduino, and that code will live on that Arduino and run the same way no matter where you take it. Each of these little numbers is a pin you can connect something to, like a switch or a light or a sensor. That's all there is to it. So how do Arduinos normally talk to computers? You push a button like this, which is connected to one of these pins. And the code will read this button. And if it's pressed, it might use this, say, serial.print command to send a message to the Arduino. It's the program running on the computer. And you can think of serial.print as like the kind of console.log of the Arduino world. Now, this all works great. It's a very, very common approach. But you need a dedicated program on your computer to read and interpret these serial messages. So every USB device is a particular class of device, like a printer or a memory card. You know, there are whole device classes, so mass storage for memory sticks or MIDI for musical instruments. And on a normal Arduino, you have two main chips. You have this one here, which is the microcontroller where your code goes. And then you have this one, which is this USB to serial converter, the interface for the Arduino to the computer. And it means that no matter what code you write on this device, this Arduino will always present itself as an Arduino device to the computer when you plug it in. Now, this Arduino, on the other hand, this also has a chip where your code goes, but it's the same chip with the USB interface on it. And that enables us to, in code, reprogram this USB device to appear as anything we want to this computer, and in particular, a device from the HID, Human Interface Device class, like a keyboard. So this is the complete code you need to create your own keyboard with an Arduino. We include this keyboard library that comes as a standard part of the Arduino install. We create a reference to the pin on our Arduino the button's connected to. We initialize it as an input, and then we begin. And then we run in this loop forever, as fast as we can, reading the pin, checking if it's low, which means it's grounded. So if I have two wires, one connected to the pin and one connected to ground, and I touch them together, that pin will be pulled to ground and it will read as low. The Arduino detects this, writes the letter A to the computer, and it's done. This is super simple and extremely dangerous. And let me try and explain why. Imagine this word here, low. If I make a typo and I write the word high, that means that if these two wires aren't touching, the moment I plug this Arduino into my computer, it will immediately start typing the letter A as fast as it physically can. And it's crazy. Like, it doesn't matter where you click or where you type. The thing's just going ah at you the whole time. And you can't probably even upload a new program to it, because before you can even click the upload, it's going ah, and your code is full of all these R's and things. So please save yourself hours of pain. And when you write this sort of code, add a small safety stop right at the beginning. And I'll share all the code in these examples in a link at the end of the presentation. And it means if the worst happens, you can plug a little wire into, in this case, pin 12 on your Arduino, and it will sit in this loop as a break, and it won't go on any further. Now, that said, as well as accidental mischief, it's very easy to cause a lot of intentional mischief with this. So, for instance, there's no reason why the Arduino has to send keyboard commands only when you press a physical button. So here's the whole program that you need to, the moment you plug this into someone's computer, probably not your own, it will do Control-A to select everything and then delete everything that's currently open and selected on the screen. Here's another one. You can leave this plugged in and running for a while. It will run in a loop on a Windows computer. It will run Alt F4 every 30 seconds, which will close the active program. Or if you're more into maybe kind of psychological warfare with one of your colleagues, then this technique's not just limited to keyboards. So you can appear as any HID device, a mouse or a joystick. And every 5 seconds, this will just move the mouse a little bit randomly in a different direction with the consequences you might expect. So I wanted to give a quick demo of how this works. I thought it would be great to build a game controller with you right now. And I was trying to think of a good one-button game that we could play together. So I thought we might try and play the Chrome Dino game. And what I want to do is I want to play this game by jumping up and down on the stage here. So I've never done this demo before. This is the plan. I'm going to create 2 panels of aluminium foil. And I'll stick them down here. And then I'm going to wrap my whole shoe in this foil. So my hope is that when I stand and short circuit between these two panels, I can create a circuit. OK. Can we see that? Yeah. So I wrote a very short program here, loads in the keyboard library, has this safety stop, attaches this button to it, and then this is it. If the button rose, then I will write a spacebar key, which is how you play the Chrome Dino game. OK, so I'm going to plug this into my computer. And I will now compile and upload this code. And that's it. So now if I click somewhere in the middle of this code, and if I touch these two things together, you should see that it's writing the space key. In this. Space isn't a very good key to choose for this demo. And now I'm going to connect one of these to one side of this foil and one to the other side. Oops. Excuse me. OK. Are you ready? No. I try once more. OK. Thank you. So this keyboard method, it works really great if you're only sending a Boolean pressed or no pressed value. But if you want to capture a more complex range of values or send a message back to the Arduino, then we need to do it over USB. And the Arduino side here is actually really trivial. If you recall this explanation from before, we use this serial.print command to send these short text strings down the USB cable. And what the Web USB API allows us to do is to capture these messages here and read them directly in the browser exactly the same way the IDE can do. So you might actually have come across this idea of plugging hardware into your browser. Like if anyone's ever updated some drone software, often drone software updaters will use this. There's also a lot of coding design tools that use this. There's actually an Arduino IDE called Arduino Create that runs entirely in the browser. And it's a sort of Arduino inception where it used the browser to upload code to your Arduino to allow the Arduino to talk back to the browser. And I should add as well that for now, this is all only Chromium only, and I suspect it will be for some time. So I'll talk to you how it works quickly. To connect in JavaScript, we call this navigator serial request port. And this will trigger a little dialog box you'll see in a minute in the browser. And I'm filtering here by the USB vendor ID. So I'm only going to see products from a company here, SparkFun Electronics. Each vendor has a unique vendor ID that they pay for. And you can find these codes actually in the Chrome device log for debugging. It's a pretty handy way to kind of debug USB issues in the browser. Now, this filtering is optional, but you must specify this baud rate. This is the rate in bits per second that your browser and the Arduino are going to talk to each other. There's a whole set of predefined values, but you only ever see two generally. This 9,600, which is probably historically kind of the default for the monitor, or a faster one, 115,200. Which is the fastest possible setting, I think, in one of the Arduino libraries. Now, the Web USB API, it makes a lot of use of the Streams API. The worst way for you to learn about the Streams API would be for me to explain it to you right now. But it's just a way of processing information that's coming and arriving bit by bit, like a file that's downloading, except here, it's about our messages that are streaming down the USB cable. So this port that we have, it has a readable stream, and we can pipe this stream through a text decoder. And that will decode it from the sequence of bytes that the serial comms are sending us into a string that we can make use of. And then when we're ready, we can make use of it with reader.read and read in the value that's there. On the flip side, sending a message is pretty similar. We pipe the writable stream from the port through a text encoder. So that will take our string into a sequence of bytes that that port expects. And then we can write a message by fetching the writer on this output stream and writing directly to it. OK, a little demo. So I've got a demo here that's going to write a message to the Arduino every half a second. And on the Arduino side, I've got a very simple program that will open the serial port, read in every character as it arrives, and spit it straight back to the browser like this. So we should see everything just echoes back as it comes in. OK. So I'm going to open the device log first and clear all of this, clear everything, and USB. So as I plug this device in now, you'll see it. It's very small, I'm afraid. You'll see it here, the vendor ID for SparkFun Electronics. And now in the browser here, I can connect to this device. And you'll see the send and receive messages coming through in the console. What's interesting to note is that some of the receive messages are getting split at a kind of arbitrary point. Hello, everyone, or sometimes split in a different pace. And this is not unexpected, but there's an easy fix for it, which I'll show you now. So what happens is, depending on exactly the timings on the serial comms when these characters are coming down the USB cable, and when they're being processed and kind of spit back to the browser, you might get this arbitrary splitting. And there's a quick fix, which I'd probably say thanks to the Chrome developer blog for the inspiration for. And what we want to do is we want to read in this stream of text and pass it through a custom transformer. And that line break transformer enables us to split it into chunks on a character of our choosing. And we can choose any character that we like, as long as we're consistent on both sides. But it's kind of pretty standard to split on the new line character. So a kind of carriage return like /R, ASCII 13, and then a new line /N, ASCII 10, for instance. That's how the Arduino would send a new line to you anyway. And I've got a quick demo of this, again, to sort of show the difference. If I can find my cursor. There we are. I'll reload this to clear that port. And connect to it here. And when you have the line break transformer, the send and receive match perfectly up like this. OK. I wanted to put this all together and give you a slightly more interesting demo. I thought we could build a small musical instrument here, which I'm going to control by stretching this sensor. So it's always good to split the tasks appropriately between the browser and the Arduino that you've got, based on what's really easy to do on each side. So on the Arduino, we can very easily read in the level of stretch. It's actually the resistance of this wire as I pull it, so the resistance it will increase. We scale it to 0 to 100 and then spit it out to the browser. And then audio manipulation on the Arduino is actually kind of a bit of a pain. On the browser, it's very simple. So I'm going to use it to create an oscillator, and then I'm going to control the frequency of this oscillator as I put on this wire. And I can show that to you all now. I'm going to connect this to these two wires on this Arduino and plug this in. Same again, I will connect to this here. See if the audio works. Is there audio from my computer? It's not the best musical instrument. Great. Thank you. So keyboard emulation and web USB, they're a lot of fun, but to be honest, the real magic is always when you connect things wirelessly. So there's a few ways you can connect with an Arduino wirelessly. There's a whole family of very popular ESP Arduino boards, which use Wi-Fi chips. But I find Wi-Fi very messy. You're always fighting with access credentials when you change location. You've got all this certificate handling for HTTPS, and it's quite power intensive on battery devices. So for prototyping, I really prefer Bluetooth. You can walk into any scenario, connect one-to-one with a device, and use it straight away. And I'm going to demonstrate this right now. I brought a couple of things I prepared with me. I've got a small bell here, and if you've got an Android phone, you can scan this QR code, or a Chrome laptop, and you can connect to this, and the first person will be able to connect to and control this bell. I've got two of them, so one will be bell green and bell red. Is anyone connected? Perfect. OK, can you put your hand up if that's you? Great. OK, you have the power now for the rest of this presentation. So firstly, browser support for Web Bluetooth is exactly the same as Web USB. It's Chromium only here. So Bluetooth LE, the low-energy part of Bluetooth 4.0. And there's basically three steps. We're going to advertise our device on the Arduino side, connect to it from the browser, and then send the data back and forth. Thank you. So first, we need to advertise it. So Bluetooth LE only allows you to connect to one device at a time, so only one of you has control of this right now. And once that's connected, the device will stop advertising, which is why none of you can see it anymore. To connect to Bluetooth LE, it uses something called GATT, these generic attribute profiles, and they kind of define how you advertise a set of services. Services have one or more characteristics in them, and these characteristics are what we read and write the data to. So you can have very standard characteristics, like a heart rate sensor or battery level, or something custom, which is what we're using here. Thank you. And as with Web USB, the data is always sent as a kind of sequence of bytes, basically. So there's two handy resources. There's a lot of good demos for this online. The Chrome developer blog has a very good explanation of the JavaScript side of it. And this Adafruit website has a really good guide to the Bluetooth side. But to be honest, what they don't do very well is explain how to get these two things talking together. And that's what I want to talk you through now quickly. Firstly, we need to advertise on the Arduino, so we give it a name. Unlike with the USB devices where we're stuck with the vendor's name, here we can choose anything we like. And you'll have seen that when you connected to these bells. And one pro tip that, in my experience, for whatever reason, you have to call getName immediately after you've set it to force it to kind of that change to be written. Now, yeah, we need to set up this service and the characteristics that we want to advertise over GATT. So I'm using this Bluetooth LE chip here from a manufacturer called Nordic. And it comes with a really handy custom GATT service which emulates UART, which is a very common device-to-device comms protocol. So that means that we have this service where we can send and receive these short little messages between two devices, which is exactly what we're trying to do here. And the other thing we need to do is to set the advertising parameters, so we can choose how long and how fast we want this to advertise for. You can pick anything you like. These are based on the Apple BLE guidelines. So they advertise for 20 millisecond intervals for the first half a minute, and then it gets a bit slower. These two numbers here, 32 and 244, they're in units of 0.625 milliseconds, just to keep you on the ball. And we set this restart on disconnect to true. So if one of you who's connected reloads the tab and disconnects from it, one of these devices will become available for anyone else in the audience as well. On the connect side, so that's the advertising done, it's basically like the Web USB. We call Navigator Bluetooth request device and connect to it. And then we connect to this GATT server, which has a handy kind of event for the disconnection that I use to trigger in the app to go back to gray when the bell is disconnected. And then we have the magic bit, where we have to connect to the service and the characteristics themselves. So what we need are these UUIDs that Nordic defined for this service and this characteristic. And there are two characteristics, one called TX for transmit and an RX1 for receive. And you've got two options to find these numbers. You can look through all the documentation that Nordic provide for this chip, or you can come to a talk at WeAreDevelopers and take a photo of this screen and read them off the stage. So once the promise is here at the bottom resolved, we'll be connected to this device. And all that's left really then is to send and receive these messages. So to send, we use this text encoder again. and we're going to write our message to the RX characteristic. Thank you. The RX and the TX, these are always from the perspective of the Arduino. So we're writing to the receive end on the Arduino. And on the Arduino side, it's just like we did with the web USB. We can check if there's any characters available, read in this byte, and then if it's the correct byte, we can ding. Thank you. The other way around, if you want to send a message back, we can write a message to the BLE UART on the Arduino side, and in the browser, we read in from the TX. We read in from the transmit characteristic. We do this reverse text decoding to convert from these bytes into the string that we want to use. And then that's it. And that's how to do the web Bluetooth. Thank you. So just to finish, perhaps one or two of you have been inspired to try out a few of these techniques for yourself. What should you buy if you want to do this? If you want to have a play with the keyboard emulation, I recommend this Adafruit Itsy Bitsy 32U4. I use it all the time. It's very cheap. It's very reliable. Actually, any Arduino that has 32U4 or SAMD in the title or description will work. This refers to the chip architecture on this Arduino. For the web Bluetooth, to make this particular method work, I really recommend this very similar looking Itsy Bitsy NRF 52840 Express. It has this Nordic NRF52 chip, so anything with this NRF52 should also work. And that's the chip I'm using in these bells here. And for the web USB, you can use pretty much any Arduino you like. So to summarize, device compatibility, keyboard emulation works with anything, any device, any browser, any program, anything that can read keyboard input. Web Bluetooth and USB are Chromium only. As I said, you're looking at these 32U4 SAMD Arduinos for the keyboard emulation, anything for the web USB, and ideally these Nordic chips for Bluetooth. The keyboard emulation is all about these Boolean press and release only. Is it on or off? Whereas you can send a byte, you can basically send any data you like on the other two. And finally, I'd say the potential for mischief with web USB and web Bluetooth is kind of limited, but with keyboard emulation, it's pretty high. If you want any of the source code for all of these demos, it's all available on my GitHub from Interaction Magic. Maybe I'll paste a link into the chat for this event as well afterwards. But thank you very much for coming along, and I hope you have a great rest of the conference.
Hi, thank you. I have some questions. The first question is, have you ever worked with X sensors? Could you share your experience about it?
Was it, have I ever worked with ANT, A-N-T? EEG, not really. This is for like, I think, not really. I know about them, I've read about them, but I'll just say no, and then maybe we can do the next question.
Did you consider using a Raspberry Pico W?
Raspberry Pico W. So I've read about it, but to be honest, a lot of my work is all about experience prototyping, where we're trying to create some physical experience as fast as possible. And so the actual architecture and the bits I use are never really important. It's all about the final result. So the quickest thing for me to use has always been the thing that's been like cheapest and most available to me. And therefore, historically, I've always used these much more kind of low-end, low-cost, these 32U4 and these other smaller processors. So I think the Pico W is really interesting because you can do a lot of interesting stuff with the way the ports are allocated between different kind of types of data and stuff. But I've never played with it, no.
Is it possible to use ESP devices from same ESP32?
Yeah, so the ESP32, I believe, is both Bluetooth and Wi-Fi in it. So you can definitely do the web Bluetooth communication with this. I don't think it has this Nordic UART kind of characteristic, which makes it very easy to just send and receive text. But you can definitely connect via web Bluetooth and send information to it. The cheaper one, the older one, the ESP866, or however you pronounce it, this one doesn't have the Bluetooth, so it won't work with this.
Are you related to Andres Iniesta?
Am I related to Andres Iniesta?
And why yes?
No. Should I know this person?
Do you have more questions, guys? There is one comment though, big applause, lots of guys to this in a live demo. I really loved it.
Okay. Thank you very much. Thank you all for coming.
There is there is last question where I can buy this.
Oh, the stretchy band. So the question was, where can you buy this stretchy band? So this again is from Adafruit, this US distributor or designer of electronic parts. So they're stocked in lots of places. Mauser Electronics is one place. There are also, in the UK, there are lots of kind of small independent electronics distributors that stock this part. It's about £7 or something. It's not designed as a stretchy band. I forget the exact purpose. I think it's for EMC, like electromagnetic interference and things, because it's a conductive rubber piece of strip. But someone discovered that you can use it to measure this kind of stretching like that. But yeah, they're easy to find online. Just search for stretchy rubber sensor and you'll come across it. You can also find the links to all these parts on that link on my GitHub.
Okay, that's it.
Thank you.
Thank you. Our next speaker is Niels Tennis, and he's going to talk about using a web assembly to run, extend, and secure your application. It's going to happen at 1:40. Thank you.